Welcome again. The homework's for the RLC circuit. So I remind you of what the differential equation is. LQ double prime plus RQ prime plus 1 over C. Q is 0, so where Q is the charge, and then L is the inductance. Just repeating the words here, this is the resistance, and C is the capacitance. So the only thing that you have to make sure is that you see that it's actually the capacitance comes in as 1 over C as a coefficient here. That's a bit strange perhaps, but that's, as I said, that's the way just how that particular field has developed. Okay, so I said number 3, and so they just tell us they say R is 2 ohms. The units are all taken. L is 0.5 henries, so that is 5/100ths. I prefer to write there. You'll see why. That makes it sometimes easier. Oh no, sorry, I'm reading the wrong question. Number 3, it is 1/10, and C is 100. Okay, and then they say Q0 is 2 coulomb and I0 is 0 ampere. So remember, I is the current. Okay, so the first thing, of course, to just plug everything in. So we get 1/10 Q double prime plus R, which is 2 Q prime, plus 1 over C. So 1 over 100, that is 100. 100Q is equal to 0. And of course we don't want to have a coefficient in front of Q double prime, so we multiply everything out with 10, so get Q double prime plus 20Q prime plus 1000 Q is equal to 0. And that, so step 1 or step, okay, the stochastic equation that we need now. Because it's constant, second order constant coefficients, so we get T squared plus 20T plus 1000 is 0. Now you could try to factor, but when the numbers get big, it's let's just jump to the quadratic formula. T is equal to, so the quadratic formula, T is equal to minus 20 plus or minus 20 squared, that is 400, minus 4 times, so minus 4000 divided by 2. And we see already that we couldn't have factored it because the result is negative. The discriminant is negative. We could have tried to complete the square, by the way, and that might actually not be so hard here. But sometimes completing the square, although it requires a little bit more manipulation, it is actually easier in calculations. But believe me, a formula, like quadratic formula, there's a reason that people don't always jump right away to it, because there's a couple of steps that we have to do. So let's see what we have to do. First, 400 minus 4000 is 3600. Now that is actually 60 squared, but there's a negative sign here. So if I do away with the negative sign, then this becomes an I, and over 2. So I get minus 20 plus or minus, 60I divided by 2. So that is minus 10 plus or minus 30I. And so when you know that this is lambda plus minus omega I, right? That is how we write our roots. We have two complex roots. We know that the solution will be by a cosine. I will e to the minus 10 t here, because we're working time t. Oh yeah, so right. So we were not gonna. I said I was gonna use this write a z here to not confuse ourselves with the time here. The number that I used called t here above was not the time. That was nothing to do with it. That was just an auxiliary variable to solve this equation here. So we get e to the minus 10t, and then we get an a cosine omega, which is 30 t, plus b cosine sine 30 t. Okay, so far good. This is q. they ask to find the current. Now, be careful. The current is I. So we're going to have to find I eventually. But they also tell us some initial conditions. They tell us that Q0 is 2 and I0 is 0. Now remember, of course, the big thing is that I is kind of the velocity of charge, right? Is the current. So this means, so the first question is, we have to take the derivative of Q to get I. But we also have an initial condition involving Q. So we should use that here too. So this means that this is at t equals 0. That's why Q0 and I0 are written that way. We plug in. So we find that I plug these two in the equation. 2 is equal to the e power. If I plug in 0, that is just 1. I get a cosine 30t. Well, that is cosine of 0. That is 1 plus b sine, and that is just 0. So we see that a is 2. Now we have to take derivative, but I'll already write that is I, so that's good to know that we have that there. Now that takes some calculation because there is a product here, so we have minus 10 e to the minus 10t, and then just copy these guys. And then we copy the first factor and take derivative of the second. That is, the derivative of cosine is minus sine, so this minus 30a sine 30t, and that is plus 30b cosine 30t. Okay, and now we plug in t equals 0, and I0 is 0, so this is 0. If I plug in 0, the exponentials are all 1, but be careful, we have it minus 10 here. This one survives, so minus 10a, this is 0. This one is also 0, so this one survives. We get plus 30b. Okay. So what does that mean? That means that that's minus 20 plus 30b. So we see that 20 is equal to 30b, or that b is equal to 2/3. Okay. So conclusion is that, okay, so we have a and b, but we should look at it from this point of view, right? So these are the ones that we have to deal with, and we should also then consider to bring like terms together. Okay, so the current. The solution is, so this is the last step, right? The actual solution. I'm using this A and this B, but I'm not plugging it into Q because I don't want to know Q. I want to know Q prime, I. So that's why I plug it in. So we have e to the minus 10t. That is always out. So let's look at the cosine term. So cosine 30t. What are the coefficients here? Well, minus 10a. So let me do this in another color, right? So this minus 10 times a. And a was 2, so that's minus 20. And there's another cosine term here. This is just a 1 here, 30b, but b was 2/3. That is so plus 2/3 of 30. Oh, but that actually cancels, right? Because this is 20 plus 20, so this is actually 0. So this whole thing is actually 0. Okay, and then plus, what is the coefficient of sine 30t? Again, we look at what we have. Sine here, we have a minus 10b, and that is so minus 20/3. And we have here a minus 30a, and a was 2, minus 60. Okay, so if we put this on common denominator, we get minus 20 minus 180 over 3, so there is minus 200 over 3. Minus 200 over 3. So we find that the current is e to the minus 10t. Let me put a coefficient in front of it. So minus 200/3 e to the minus 10t. Where are we? Sine. There was sine that revised. Sine 30t. Okay. And the okay, so I just want to double check that this is that I don't have any of these numbers wrong. What did I do? 6.3 number 3. Yes, so this is correct.